Okay, this is the video that's going to help you with stoichiometry number 2. Now, I am not going to do all 5 with you that you have to do, which hopefully you read the email that says you only have to do 5. If you do more than 5, that is extra practice. It is not extra credit. Okay. You need to try to write these equations yourself. Okay. I'm not going to write them for you on the test. So you're going to need to do that yourself. And I'm staying after school on Tuesday if you need help. So plan on staying after. Okay. Remember that we use our mole map. We will be writing balanced every single problem to get these solved. Okay. And we need a periodic table for molar masses, but we don't use molar mass every single time. So I'm one with you that we don't even use molar mass at all. Okay. This first one we do though. So how many molecules of carbon dioxide gas are produced in a combustion reaction between 35 grams of methane gas, which is CH4, and excess oxygen gas? Okay, so let's first just write our equation. So this is a recall back from chapter 11. You should remember what a combustion reaction's products are. But for now, we know that the CH4 reacts with oxygen gas. So look over at the Hunkel fiber poster. That means that O gets a 2 when it's by itself. Okay. The products for a combustion reaction every single time, one of them is carbon dioxide. So one of them is CO2. And the other one, you need to remember this, is H2O, water. Okay. So now let's balance. We've got, with combustion reactions, always start with your carbons and then hydrogens and then figure out the oxygens last. So carbons match right now. Hydrogens, we need 4 on the product side. So we'll put a 2 in front of water. And then for the oxygens, we've got 2 from water plus 2 from the CO2. So that makes a total of 4. So I'm going to put a 2 as the coefficient in front of O2. Okay. So now that we got our balanced equation, let's figure this out, how we're going to use the mole map. So first question, how many molecules of carbon dioxide gas? So we want to know the molecules of the CO2. So that makes the CO2 our 1. Okay. The number that we have to start with, the 35 grams, belongs to the CH4, the methane gas. So that makes the CH4 our have compound. Okay, so then at this point, we've figured out our want and our have. No longer need the O2 and we no longer need the H2O. So if it's helpful, cross those out. Okay. Now we start putting up our parentheses. So parenthesis number 1, we are going to put the number that we're given over 1. So we've got our 35.0 grams, and we put what kind of grams, CH4, over 1. I forgot to open my mole map. Here it is. Okay, as it opens, then now I forgot to say this. On our problem, I think I did this in the notes. Sometimes it's helpful. Back when we did in chapter 10, we would also figure out our starting points and our ending points in relationship to the mole map. Okay. Remember, the start is the unit on the number. So that would be mass because we are starting with grams. And then the end is where we're traveling to, which circle, so that we solve correctly. And the question is asking us to solve for molecules. So that means we are going to the RP circle so that we get our molecules. Okay. So that means we're not going to loop around. like we did last week. What we're going to do on our mole map is, oh, come on. We are going to start in the mass. Then we're going to travel up to the mole ratio doing this part. So that's going to be parenthesis number 2. The mole ratio is going to be parenthesis number 3. And then from there, we'll travel to the RP circle and we'll use that for our 4th parenthesis. Okay. So parenthesis number 2, we already did number 1. So number 2 is this. And we remember this is a half step. Every time that you go towards the mole ratio, it is a half step. So going back here, we are going to put 1 mole of the compound we have, the CH4, over the molar mass of CH4. So you would look up hydrogen is 1.008 on the periodic table times 4 plus a carbon, which is 12.01115. And I have a really exact molar mass here. If you did it yourself and you got something slightly different, that is okay. Use your number. I got 16.0426 as the molar mass of CH4. Okay. At any point, if I'm going too fast, please just pause the video and write it down. Okay. That's one of the benefits of watching a video to help you instead of being in class and getting lost. So now the CH4 grams are gone. So now we are going to be in our mole ratio in that center circle. So that is moles 1 over moles half using the balanced equations coefficients. Now, the nice thing is with this equation, both of the coefficients are nothing or 1. Okay. So if nothing's there, you plug in a 1 and it's 1 over half. So 1 mole of the CO2 over 1 mole of the CH4. And the reason why the CH4 goes in the denominator is so that the moles of CH4 cancel out. Remember, we don't cross off numbers. We only cross off units when we're crossing things off. Okay, and the last parenthesis. Now, this is different than last week. Okay, we are going to the RP circle. So to go to the RP circle, we are going to use the Avogadro number, 6.02 times 10 to the 23rd. We haven't used that in a while. So in the numerator, because that's what the arrow said, 6.02 times 10 to the 23rd. Remember that it says particles there, but we put the particles we're talking about in the problem. And those particles are molecules. So I'm going to label that molecule of CO2. And then in the denominator, it'll be 1 mole of CO2. So it's still a want step. Okay. But the difference now is that we don't need to find the molar mass of the CO2. We're going to use Avogadro's number instead. So now, then to solve, we have to use our double E button on our calculators at the very end. So way I would type this in your calculator, 35.0 divided by 16.0426. The 1 over 1, we can just forget about, right? We can just forget about ones. But then times 6.02 double E 23. And you should get for your answer, I already have mine rounded in significant figures, so that's helpful, I guess. 1.31 times 10 to the 24th molecules for sure as your label, CO2 optional. Okay. Now, if you got like times 10 to the 23rd, that tells me that you typed your scientific notation in wrong. Okay. So just be careful with that. Don't do times 10 to EE. Just the double E takes the place of the times 10. Okay. So that was one of your 5 that you were going to do. Let's do another one. I want to do another one that has no grams involved. So that means less work, really, if you don't believe me, we'll see it in a second. And then also, I just want to show you what I mean on the back side. So we're going to do number 8 for our other one. Okay. And the reason why I said I want to do this one is because of this hint thing. There are only going to be 3 parentheses to solve because we are going to start or end in moles. Okay. When we first learned how to use our parentheses stuff, we had 2 parentheses. Then on Friday, we learned how to do 4 parentheses. And now we can do 2, 3, or 4 parentheses. Okay. We just get in habits of going with 4, but I want to show how you just need 3 for number 8 and no molar mass, which makes it easier. Okay. So calculate the number of moles of iron metal used in a single replacement reaction. That should sound familiar, between iron and hydrochloric acid to form iron 2 chloride and 1.043 liters of hydrogen gas. Okay, first thing we do, write the balanced equation. So the reaction between iron metal, so that's just Fe, and hydrochloric acid. This was on the test. Did you remember? Hydrochloric acid, we use it in the lab a lot. It's just HCl. Okay, we actually did this reaction in one of our labs in chapter 11. Iron 2 chloride, the Roman numeral 2, remember, means that iron has a +2 charge. Chloride is Cl with a -1. So the formula for that will be ECl2. And another product is this hydrogen gas. And if you look over on the poster, I forgot to say this about the iron. The Fe does not get a 2 because it's not on the Hunckel fiber poster, but the H does get a 2 because it is on the poster. Okay. So before anything else, we need to balance, and we will balance when we put a 2 in front of the HCl. Okay. So now calculate the number of moles of iron metal. So that means that we want to know the number of moles of the Fe. So that makes the Fe the wanted compound. And if we're thinking in terms of start and end on our mole map, the end is the unit. So we are going to end in the mole ratio circle. Then the number that we start with, the 0.43, the 1.043 liters, belongs to the H2, the hydrogen gas. So that goes there. Liters is just an L. Remember that from before? And so the H2 is our have compound. And liters is in the volume circle. So we are going to start in the volume circle for our traveling on the mole map. Okay. So at this point, the 2HCl no longer matters. The FeCl2 no longer matters. Okay. Parenthesis number 1, put our number given over 1. So 1.043 liters of H2 over 1. Okay, now let's see how this is not going to be 4 parentheses. Okay, remember that I told you one of the tricks is that the number of circles you touch plus 1 tells you the number of parentheses you have. Okay, so our first parenthesis, we said we're starting in the volume. We're starting up here. So that's the number 1 circle. And we are traveling to the mole ratio circle. So that's the second circle. So 2 circles means 3 parentheses in our problem. So we've already done the first parenthesis. So parenthesis number 2 will be 1 mole over the 22.4 liters. And this is a have step. And our third parenthesis, because we have to do this, we have to switch it. We will do the mole ratio as our third parenthesis. So parenthesis number 2 we're going to say 1 mole of what we have, the H2, over the 22.4 liters that we're getting from our mole map. And this is a half step, so I labeled it as H2 because that's the half compound. By doing that, that allows us to cancel out the liters of H2. Don't cancel the numbers. Okay. And then the last parenthesis is our mole ratio. Moles want over moles have. And we want the Fe, which has a 1. So 1 mole of Fe over, we have H2, which is also a 1. So that's kind of nice. 1 mole of H2. And that cancels out the moles of H2. Okay. Now, when you solve, we can forget about that third parenthesis since it's 1 over 1. And we're done because when we're done, we will get what the answer is asking for, the moles of the iron. Okay. So all we have to do is take the 1.043 divided by 22.4, and it is going to be a very small number. When we round, both of the zeros at the beginning of the answer do not count as significant figures. Both of them, not just one of them, both of them. So we have 4 sig figs in our original number. So we have to go to 4 decimals after this first 0. So the final answer rounded correctly will be 0.04656 moles of Fe for that. Okay. So now that was your second out of 5 questions to do. So you have to do 3 more yourself. You will need to write a balanced equation for each one. Perhaps you should try to write the balanced equation part and go up and ask kindly to check the answer key to make sure you wrote it correctly, and then attempt the problem. If you want some easier ones, you don't have to do this, but if you want some easier ones, numbers 5 and 6 do not require molar mass. So that means that you have one less thing to do to get to the final answer. Both of those do have 4 parentheses across though. So that's still filled in, but it's just not filled in with molar mass. You use Avogadro's number, you use the 22.4, that kind of stuff. On the front side, every single one of them has molar mass at some point. Okay, so this is going to be due on Tuesday. Good luck. I hope I helped you get started well.